This video is for in class 38, finding composition of functions. So we're first going to start through with just some solving or simplifying equations, and then we are going to work through two compositions and then just work through the process of what the actual standard asks you to do. So with that, we're going to just take the function of d and we're going to plug 3y in for x. So you see this is d of x, and we're going to substitute in 3y. So we're going to create a new equation. So d is here. So I have 3 times x squared plus 6 times x minus 10. Now, I'm not writing x because I'm going to substitute in 3y wherever x is. So this is 3y and 3y. So this new equation, before I do anything, is going to kind of change. So 6 times 3 is 18, so this is going to be plus 18y minus 10. But before I can times by 3, I need to actually take 3y times 3y. So 3y times 3y is 9y squared. So if you're unsure what this means to do, you're going to take 3y times 3y, which gives you 9y squared. Now, I'm going to simplify this, and then see if I need to simplify any further. So that gives me 27y squared. And if I have 27y squared, I cannot simplify 18y and a negative 10 anymore, so it's going to be plus 18y minus 10, and that's my answer. So the composition is where you take a function, and you're going to take all its values, plug it into another function, and create a brand new function. So mainly the domain of this function gets you, all the x's from here, gets you a new answer out of this function. So I'm going to do cy cubed. So c is, excuse me, c is this 4x cubed minus 5x. So I'm going to take 4 times x cubed minus 5 times x squared plus 2. And I'm going to plug in y cubed to that. Y cubed. And I'm going to take y cubed times itself 3 times. So as you can see, when you have a base with exponents right next to each other, you have 3, 6, 9. You just add them, or you just multiply your exponents, so that becomes y to the 9th. Y cubed squared would only be 2 of these, which would be y to the 6th. And so I still have this times 4 minus this part times 5 plus 2. So I'm going to simplify here. I'm going to get 4y to the 9th minus 5y to the 6th plus 2. And I can't simplify it any further. The next part is a little bit more complicated, but this is compositions, so we're going to build a little bit more. So d is 3 times the quantity, x squared plus 6 times x minus 10. Now on this question, I'm just going to go back over here and write this in black because I switched my pens on myself and didn't even realize it. I'm going to plug in x plus 3. So x plus 3, x plus 3. Now over here on the right side, it's going to be quite easier. So I'm going to take 6 times x and get 6x. 6 times 3 plus 18 minus 10. I'm going to simplify this down to 6x plus 8. Over here, I actually need to take x plus 3 times x plus 3. So I need to distribute that out. And when you do that, you'll get x squared plus 6x plus 9. So in my parentheses, I'm going to have x squared plus 6x plus 9 with a 3 still in front of it. Okay, so then I'm going to distribute the 3 times each part, and I'm going to have 3x squared plus 18x plus 27 plus 6x plus 8, and then I'm going to combine like terms. So 3x squared doesn't combine with anything. 18x plus 6x gives me 24x, and 27 plus 8 is 35. So that's that composition. So what you're doing is you're literally taking a function and plugging it into another function and simplifying it. So f of x and g of x are just two function names instead of like what we had just up above with c's and d's. And then we have a cheese pizza and a pineapple. This composition here is where I take the cheese pizza, I have that, and then I make changes to g of x. So g of x was a pineapple, so I cut it up in some way. I did something with it. And then I plugged it into or onto f of x. So this function here is f of g of x, which is also f composite g. Okay. This function, I made the pizza, cut it up, and then I put it on the pineapple that was cut up. So I have g composite f of x, which is the same thing as g composite f. Okay. So what we're going to do is we're going to ask you on the test to do f composite g and g composite f, or g composite h, h composite g. With those, performing the compositions of the functions, I would do an example here. I'm actually just going to show you an example of what I've done previously, just to show mathematically what this means. So what you got going on here is we started with a function, g of x, okay? And I said it was 3 plus x. And then I said I'm going to evaluate g at 5, okay? So when I got g of 5, I plugged into the equation, I got 8. And then I said the function f of x equals x squared plus 2. So I'm going to take that equation, I'm going to get f of 8, plug it into this equation, get 66. So what I did is I took a number, plugged it into g of x, got an answer, took that answer and plugged it into f of x, and got a new number, which is 66. What you can do instead is you can do what is called a composition. If you do a composition, you can take whatever function that you're starting with, plug it into your secondary function, simplify it out, get a number. So 3 plus x squared, simplified out, comes out to equal x squared plus 6x plus 11. So this composition, which is like over here, if I then just said I wanted to find 5 in it, you would get the same answer. So when you're doing a single value, it is quicker to plug in a small function and then take that answer and plug into the next function. But when you're trying to write an equation for everything, you're going to want to actually take the time to find out what equation you're going to use to answer any type of question. So with that, what we're going to do is we're actually going to create the functions. So if you do not recall what is compositions where you're just taking a function and plugging it into another one. So we are always taking the second function and plugging into the first. Okay. So we're going to do g composite h. Okay. Where g is the red and h is the blue. So what does that mean? That means I'm going to take the function of negative 3x, so negative 3x, and I'm going to take this h function, I'm going to plug it in wherever there's an x in g, which is just this single x, so I have 4x minus 1. So I'm going to distribute that out and simplify it. So negative 3 times 4 is negative 12x. Negative 3 times negative 1 is plus 3. So my composition, g composite h, equals negative 12x plus 3. So h composite g is doing the same thing but backwards. We have our red function and then our blue function, and we're going to take our red function and plug it into h. The red function is negative 3x, so I'm going to write down negative 3x here where I want the x to be. And then I have 4x, so negative 3x is in for x minus 1. I'm going to distribute this. 4 times negative 3x is negative 12x. And then I don't multiply anything, so just minus 1. So this equals h composite g. All right, gonna do that again. So g composite h composite g. G is equal to 5x plus 1. I'm going to plug in x squared plus x minus 1. I'm going to distribute through this, so I get 5 times x, which is 5x squared, plus 5x minus 5 plus 1. Simplify anything I can, so g composite h is going to be equal to 5x squared plus 5x minus 4, and that's it. So on the next one, same thing, but there's more x's. So I have an x squared plus an x minus a 1. So where I have x squared, I'm going to take and plug in g of x. So I have 5x plus 1, 5x plus 1. And I'm going to simplify the second part here. So I have no distribution. So this is going to be plus 5x plus 1 minus 1. And then this here, I actually got to take 5x plus 1 times 5x plus 1. So I'm going to get 25x squared. I'm going to have a plus 1 here. And then 5 times 1 and 1 times 5 is going to give me a 10x. So plus 10x if you need to show all your work and you can't do that quickly, by all means, show all the distribution. So combining like terms, I'm going to get h composite g equals 25x squared. 10x plus 5x is plus 15x. 1 plus 1 is 2, minus 1 is 1. So my answer is 25x squared plus 15x plus 1. All right, last but not least, we have one more. I'm going to change my orange to a darker orange. So I'm going to find G composite H, and G is x plus 2. I'm going to plug in 2x squared minus 3 into there. And simplify it. There is no distribution I need to do. So I have 2x squared, negative 3 plus 2 is a negative 1, which equals G composite H. H composite G equals 2 times the quantity of something squared. Whoops, wrong colors. Let's try that again. You don't have to color code, but it helps when you're learning. 2x squared minus 3, and I'm going to plug in x plus 2. So before I do anything, I have to actually take x plus 2 times x plus 2. So I'm going to have this 2 on the outside times that product minus 3. So x squared plus 4x plus 4, and then I'm going to distribute. 2 times x squared is 2x squared plus 8x plus 8 minus 3. And my final answer will be H composite G equals 2x squared plus 8x plus 5. And then if you need to, make sure you go back, box your answers. If you don't have labels on your answers, you will be wrong because I will not guess the correct answer that which one goes with which. So you'll need to find what makes you happy on that. There you go.